Hi everybody, this is your math teacher, Mr. Kramer. Today we're going to look at radicals as we move towards solving equations using the quadratic formula. So, in memory of my student from last year, Lindsay, she always said, Mr. Kramer, could you please use more color in your videos? And so, in memory of her, I will be using different colors in my video today. If any of you have any suggestions for improving my video, except, of course, changing my voice. This is the voice God gave me, so I'm going to use it as it is. Let me know. So let's get to it. It says simplify the following radicals. So in order to simplify a radical, you want to take the number underneath. And my suggestion is to write out its factors. So we got 1 and 56, 2 and, let's see, 28, 3 and, maybe 3 doesn't go into it. Don't think so. Let's try 4. 4 and 14. 5, no. 6, no. 7, yes. 7 times 8. Okay, so those are all the factors. So when simplifying a radical, what we're looking for is the perfect squares. So do y'all see any perfect squares in here? Yeah, right there. Right there, there's a perfect square. So we want to use this. We want to break 56 down to the square root of 4 times the square root of 14. Remember, we're looking for the perfect square. Then the square root of 4 is 2 and the square root of 14. And that is the simplified version of the square root of 56. Okay, let's take a look at number 2. So remember, we're looking for the factors of 324. Now, you may not like this big number, so if you have a calculator available to you, if you plug in to y equals 324 divided by x, and then go to your table, it will list out all the factors, starting off with 1 and 324, 2 and 162, 3 and 108, 4 and 81. Well, there's a perfect square right there. But let's see if there's a bigger one. Let's keep going. 6 and 54. No perfect square there. 9 and 36. There's a perfect square. Actually, they're both perfect squares. How interesting. Let's use that one, 9 and 36. All right. So we're going to have the square root of 9 times the square root of 36. The square root of 9 is 3. The square root of 36 is 6. So the answer is 18, which means the square root of 324 must be 18. What was it, 324? And it is. It's a perfect square. Nice. Okay, I'm going to go ahead and let you try number 3. Let's go ahead and do number 4 together. Let's go ahead and break 300 down. I'm going to go ahead and use my calculator again. So 300 divided by x. Go to your table. Oh, look at there, 3 times 100. Man, I should have thought of that. 100 is a perfect square. 3 times 100. So we're going to have 5 times the square root of 3 times the square root of 100. 3 times 100 is 300. Okay, so it's going to be 5 times, and I'm going to go ahead and do my perfect square next, so 5 times 10 times the square root of 3. So I'm going to get 5 times 10, which is 50, times the square root of 3. And I have simplified that answer. Okay, let's go down here and let's solve using the square root method. Okay, so the square root method means when we're using the square root method, we're just solving for x, just like normal. So what does that mean? That means that we're trying to get x by itself. Okay, so if I'm trying to get x by itself, then we're going to have to cancel out the minus 49. We're going to bring down the x squared and the 49. Okay, and then to cancel out a square, we're going to square root. The square root and the square inverses, they cancel each other out. So if I take the square root of this side, I have to take the square root of this side. So those cancel, we get x equals, and then the square root of 49 is going to be a positive 7 and a negative 7. Because 7 times 7 is 49, and negative 7 times negative 7 is also 49. So both answers will get us 49. So we have two solutions. Okay, let's take a look at number 6. Number 6, again, let me remind you, using the square root method means to solve for x. So we're not factoring. We are not solving by factoring. Okay, so we're going to add 27 on both sides. Okay, we're going to bring down the 3x squared, bring down the 27. We're going to divide by 3. We get x squared equals 9. And then if you recall how to get rid of a square, we square root both sides. The square root cancels out the square, so we get x equals the square root of 9. And we're going to go ahead and do positive 3 and negative 3. 3 times 3 is 9, and negative 3 times negative 3 is 9. In order to get both roots, let me show you on the calculator. So plugging in the equation into y equals, going to graph, as you can see, we have two solutions, negative 3 and positive 3. So when you take the square root of 9, you have to give me the positive root and the negative root. Okay? All right, let's take a look at number 7. We're going to add 48 on both sides because we're trying to solve for x. So we get x squared equals 48. We're going to take the square root of both sides. And so, remember the square root cancels out the square, so we get x is equal to the square root of 48. Now it's going to be plus or minus the square root of 48. Well, I do expect you to simplify your radicals. Now, we just did that up here. So let's simplify square root of 48. So remember, we write down the factors of 48. So let's recall. Factors of 48. Remember, if you want to get the factors of 48 without doing a lot of multiplying in your head or dividing, 48 divided by x, we're going to go to our table, and right there we have 3 times 16. What are we looking for? We're looking for a perfect square. 16 is a perfect square. So we're going to use 3 and 16 as our two numbers, since 16 is a perfect square. So we're going to have plus or minus the square root of 3 times the square root of 16, okay, equals, and I'm going to go ahead and do my square root of 16 first. So I'm going to have plus or minus 4, and then I'm going to leave the radical on the 3. I do expect you to simplify your radicals if possible. If it's prime or it doesn't factor into a perfect square like this one does, then you just leave it. Okay? Go ahead and try number 8 on your own. Number 9, it says factor completely. Well, it's quadratic. So we could use the x factor here, but we're going to get a really big number on the top, aren't we? So my suggestion here is notice that you can factor out a 2 out of each one. Anything bigger than that? I'm thinking maybe a 4. Does 4 go into 60 evenly? I believe so. So factoring out a 4. Remember, factoring means to divide. So 8 divided by 4 is 2. 4 divided by 4 is 1. 60 divided by 4 is 15. And I just bring the signs down. So this is going to be a little bit easier to factor. So to get our top number, we take our a value times our c value. Our b value goes below. Two numbers that multiply to give us negative 30 and add to give us negative 1. So I'm thinking 6 and 5. And I'm thinking I want a negative 1 when I add them. So I'm thinking a negative on the 6. Writing my two ratios. Remember, my a value goes on top. My factor goes on the bottom. Reduce, if possible. So 4 is a factor, so that stays down here. First one's going to be 1x minus 3 and 2x plus 5. And we factored it. Now remember, I don't want any confusion here. We have factored it completely. Now, this is not factored form. Here we have standard form for a quadratic. If we wanted this in factored form, remember that we'd have to factor out the 2 out front so that my a value would be the same. So don't get confused on that. We're just writing this in fact as factors. Okay, so this is factored completely. All right, well, we're approaching the 15-minute mark, and I hope you guys are having a good night. Don't forget to watch the sequel video and take those notes, and you have until Friday to do that. So I'll see you guys in class tomorrow. Hope you guys are having a good night.